Assalamu alaikum wa rahmatullahi wa barakatuh. Good evening, seven students. Welcome to today's first session. I'll be walking you through the topics we've treated for the term. That is introduction to science, introduction to chemistry, scientific method, basic chemical technologies, laboratory safety and personal protective equipment. And then our last topic, physical and chemical changes. Now, what is science? We said science is the study of the world around us. The branches of science are biology, physics, earth science, chemistry, environmental science. And uses of this science, they are used to improve our health, they are used in agriculture, in technology, in transportation, and also in problem solving, that is finding solutions through experiments and research. Now, who is a scientist? A scientist is a person that devotes his or her life to study science. We also looked at some of the famous scientists. We looked at Jabir ibn Hayyan, father of chemistry, who discovered distillation, evaporation, and crystallization. Also, Isaac Newton, physics scientist, Charles Darwin, political scientist, and then that will take us to introduction to chemistry. Chemistry is the study of matter. We said matter is anything that has mass and take up space. Now, branches of chemistry, we have the organic chemistry, the inorganic chemistry, the physical chemistry, analytical chemistry, biochemistry, industrial chemistry. Importance of this chemistry, we have it provides raw materials for industries, improve health through medicine, helps food production and preservation, used in environmental protection, also contribute to the technological development. Now, the scientific method. The steps in scientific method, we have question, observation, question, hypothesis, experiment, and conclusion. Basic chemical terminology is atom. What is an atom? An atom is the smallest particle of an element that takes part in chemical reaction. We have the oxygen atom, the nitrogen atom, the hydrogen atom. Then we have molecule. Molecule is formed when two or more atoms combine chemically. So atom is the basic, and molecule is teamwork. That is when two atoms come together. It doesn't have to be the same atom. Two hydrogen, oxygen plus oxygen, we have O2. Hydrogen plus oxygen, we have two hydrogen plus one oxygen. That will give us H2, which is water. Elements. What are elements? Elements are pure substances made up of only one type of atom, cannot be broken down into simpler substances. Now, think of your oxygen, your gold, your helium, beryllium, lithium, they are all elements. And each element consists of, if, for example, if we're talking about oxygen, elements consist of oxygen atom. And we have compounds. Compounds are when two or more elements are combined chemically together. We have our salt, NaCl. Then we have mixtures. A mixture combines substances physically, not chemically. That is when two compounds come together, they give you mixture. They are combined physically. Say, for example, NaCl is salt, H2O is water. When I combine the two together, that's a mixture. That is NaCl as a compound, H2O as a compound, combined physically together, that is a mixture. Sand as a compound, water as a compound, combined physically together, that is a mixture. Mixture can be homogeneous, it can be heterogeneous. And homogeneous, when they are uniformly combined, you cannot see the particles. Heterogeneous, when they are not uniformly combined. Now, what are lab safety rules? These are the safety precautions we carry out to ensure it's an accident-free experiment. Now, we have always followed teachers' instruction carefully, no eating, no drinking, no running around in the lab, report all accidents immediately, never walk alone in the lab, keep your books and bags away from your work area. Personal protective equipment, we have your safety goggles, lab coats, gloves, closed-toe shoe, face masks, or respirator. And the last topic, which is change. Change is the process in which a substance becomes different from its original form. This can happen in two ways: the physical change and the chemical change. A physical change is a change in the form, appearance, or state of the substance without forming a new substance. It can only change in its form or in its appearance or in its state. That is, can change from solid to liquid or gas. Now, examples of this physical change, we have melting of ice. If I melt my ice, it is still water. It is not giving me a different substance. We're still working with water. Now, if I boil water, the water escapes to steam. If I don't want it to escape and I cover, now say for example your food, when you bring food to school, when you open your cooler, you see water coming out of the lid. Did you pour water there? No, it is the steam that is going back to water. So you see, even if water should boil to steam, it is still water, because if you cool the steam, that if the steam will condense, it will still give you water. Dissolving salt or sugar in water, it might appear dissolved, but you can still recover your salt or sugar when you place that water on fire and then the mixture on fire and the water evaporates. Breaking a glass, cutting paper, the glass might appear shattered, the paper might appear pieces, but it is still paper. Then freezing your water back to ice also. Characteristics of physical changes: no new substance form, it is reversible, that is, you can take it back to the original form. Only physical properties changes, that is the size, shape, color, and state. It involves little or no energy, no permanent change at all. And chemical change is a change where a new substance is formed with different properties from the original material. Examples: burning of paper. When you burn paper, you get charcoal or ash, a different substance with different properties from the paper or wood. Rusting of iron. Rusting can occur when the iron is exposed to oxygen and moisture. We can say air and water. It becomes rust and you cannot get the original iron back. Now, cooking of food. When you fry your egg, you cannot get the raw egg back. When you boil your rice, you cannot get the raw rice back. Digestion of food in the body also. And characteristics of chemical change: no new substance are formed, it is irreversible. Unlike the physical change, you cannot reverse the chemical change. Now, energy is often absorbed or released. Permanent change in properties. Gas or precipitates may be produced. Now, how do you know a reaction has taken place, especially a chemical reaction? There will be color change. In some cases, you see a new color will appear. For example, if I have my wood and the wood gives me charcoal and ash, not the same color as the wood. Gas form. At times, you see bubbles when you mix two chemicals together. Not because you've put a dishwash or soap inside. And that bubbles is showing that a gas has been released. Then energy change. It can become cold, it can become hot. That is as a result of energy being absorbed or energy being released. And precipitate forms. What is precipitate? You see solid in liquid. Not that you are done putting the solid. Say for example, if you have a mixture or a solution of milk, when you dissolve your milk in water and you add drops of lemon in it, you see some of the milk coagulating, that is coming together to form balls or a solid, like they'll come together. You see them coagulating in the mixture. Now, those ones that come together and coagulate are the precipitates of the liquid, and that is all about change. Please do well to read the book and write your name in the comment section with any question you have. Meet in the comment section. Bye. Assalamu alaikum.